Okay, good afternoon. I want to go over the GCF and distributive property. Some of you are misunderstanding what the instructions are. Um, like for this one, 90 plus 27, I did not want you to just add these. I wanted you to look at the video. And so first, we're going to write this in like reverse distributive property. Um, so we're going to find the GCF here. As soon as I get a pen up. Okay. So we want to find the GCF of 90 and 27. So it looks like they're not both even, so 3 will go into both of them. 3 goes into 90 30 times, and 3 goes into 27 9 times, because 9 times 3 is 27. Also, both of these numbers are divisible by 3. So 3 goes into 30 10 times, 3 goes into 90. Did I say it right? 3 goes into 30 10 times, 3 goes into 9 3 times. 3 times 10 is 30, 3 times 3 is 9. So here is my GCF. And remember, the distributive property over addition is going to look like this. We're going to have a number on the outside and 2 numbers here. The number here on the outside is my GCF, which is 9. And then these 2 numbers here go inside. Remember, we keep down till we get to something that's only divisible by 1. So let's look at this one. 11 plus 66. So I'm going to put my 11 here and my 66 here. Well, it looks like 11 goes into both of these. 11 goes into 11 one time. 11 goes into 66 6 times. So I have 1 and 6. The only thing that will go into the both of them is 1. So we're done. And so in our format like this, number plus a number. The 11, the GCF, goes here. And then these 2 numbers go here. I included another video from someone on YouTube that may be easier for some of you to see. Okay, this is supposed to come over here too. Okay. So now I'm going to move this up. We have 2 more here. So we have 44 plus 24. So again, we want to find the GCF of 44 and 24. They are both even. They're both divisible by 4. 4 goes into 44 11 times. 4 goes into 24 6 times. You could have started with 2, but you would have had 2, and then you'd have had another layer to your cake. 4 times 11 is 44. 4 times 6 is 24. Some of you have said you don't like this method. This method is actually more compact, and it doesn't take as long as the other methods. You would have to keep writing numbers out. Okay? So here is my GCF. That goes on the outside of my parentheses, and inside my parentheses, these 2 numbers. Okay? So we're not simply adding these. That's second grade. We are finding the GCF, and what we're doing is called factoring. That's a term we haven't used yet, but that's what we're going to. It's called factoring, okay? So here, 51 plus 27. Let's see, 5 plus 1 is 6. That's divisible by 3. 2 plus 7 is 9. That is divisible by 3. I don't know what 3 into 51 is, so I'm going to go over here. 21. So that's 17. 3 goes into 27 9 times. 17 is prime. So nothing else goes into it but 1. So in my format. And I've posted these before, but some of you are still giving me incorrect answers on this one. Okay, let's look at one more set. Yeah, that's the one I want. Okay, so let's look at this one. See if I can make this a little bit bigger. Okay. So this is 33 plus 30. So I'm going to have to work this over here to the side or on my scratch paper. So even though we're doing digital learning, we still need scratch paper, people. So 33 plus 30. I'm going to come over here. Let's see. What goes into 33 and 30? I'm going to guess 3. Yeah, because 3 plus 3 is 6, so that is divisible by 3. And of course, 30 is divisible by 3. 3 goes into 33 11 times. 3 goes into 30 10 times. So what goes into 11 and 10? 1. So 1 and done. So this is my GCF. That goes on the outside of my parentheses. And then my 11 plus 10 goes on the inside. What if this were a minus? Then this would be a minus. I don't know why this is right here. Okay. Let me see if I can move that up. Okay. Now let's do 6 plus 18. That should be pretty simple. So we're going to find the GCF again. What goes into 6 and 18? I know it's 6, but let's start off with 3. 8 plus 1 is 9. 3 goes into 6 2 times. 3 goes into 18 6 times. These two are also divisible by 2. 2 goes into 2 1 time. 2 goes into 6 3 times. So here's my GCF. See, I would be doing this on scratch paper on the back of my paper. 3 times 2 is 6. Don't try to sit and do these in your head. I can't do them in my head. Well, some of them I can, but most of them I can't. We want to use scratch paper. So here's my GCF that goes on the outside and inside my parentheses. 2 plus 6. Now you can pause this video at any time to redo it. To try these again. So let's go to the next one. And I want you to pause the video and try to do it yourself. 30 plus 16. Okay, I'm assuming you have paused the video and are coming back to it. Okay, trying to get the black. So I have 30 plus 16. So I have to find the GCF. Okay. Now what goes into 30 and 16? They're both even, so let's try 2. 2 goes into 30 15 times. 2 goes into 16 8 times. Let's see. Factors of 15 are 3 and 5. It's divisible by 3, but 8 is not. So we're down to 1. We're 1 and done right here. So my GCF, 2, goes on the outside. Y'all getting it? Okay, number 4. Pause the video, try it yourself, and then we're going to come back and do it. Okay, so now the next one is 27 plus 39. So we need to find the GCF. Let's see, they're not even. 7 plus 2 is 9. That's divisible by 3 and also 9. 3 plus 9 is 12. That's divisible by 3. So we're going with 3. 3 goes into 27 9 times. 3 goes into 39. I think it's 13, but let's double check by going over to the side and doing a little division. 3 goes into 1 3 times. 3 times 1 is 3. I subtract. 3 goes into 9 3 times. And that's 0. So it's 13. I guessed it was. So I have 9 and 13. So I'm 1 and done because 13 is prime. So my GCF, 3, goes on the outside, 9 plus 13. So you see, when you get down to 1 and done, those are the numbers that go right there. All righty. Number 5. Okay, let's pause and see if you can do number 5. Okay, we're back. So we have 9 plus 21. So 9 and 21. Let's see, 2 plus 1 is 3, so that's divisible by 3. And 21 is divisible by 3, and 9 is also. 3 goes into 9 3 times. 3 goes into 21 7 times. 3 and 7 are prime, so I'm one and done. 3, that's this 3, and then 3 plus 7. So these numbers here are the ones that go inside your parentheses. 45 plus 30. So I'm going to find the GCF of 45 and 30. Ends in 5, ends in 0. So that's divisible. Both of them are divisible by 5. 5 goes into 45 9 times. 5 goes into 30 6 times. Woo, I got 9 and 6. Both of those are divisible by 3. 3 goes into 9 3 times. 3 goes into 6 2 times. 3 and 2 are prime. Did you know that 2 is the only even prime number? So 3 and 2 are prime. Here's my GCF, 5 times 3, which is 15. Let me go ahead and write that. 5 times 3, which is 15. So that goes here. My GCF always goes here. And then my one and done numbers, 3 plus 2. That goes inside. Okay, let's try to work number 7. Oops. And then we're going to pause the video. I'm going to pause the video and try to work number 7, and then we'll come back. Okay, we're back. Number 7 is 6 plus 12. So I'm going to find my GCF. 6 and 12 are both divisible by 6. 6 goes into 6 one time. 6 goes into 12 2 times. I'm down to 1 and 2. I'm done. 1 and done. GCF, 1 plus 2. Number 8, let's pause, see if you can do it, and then we'll come back. Okay, so hopefully you paused the video and you tried to do it yourself. Let's check your answers. We have 4 plus 18. So 4 and 18 are both even. So we know that 2 goes into both of them. 2 goes into 4 2 times, because 2 times 2 is 4. And 2 goes into 18 9 times, because 9 times 2 is 18. So this is my GCF, which goes on the outside. And then these two numbers, right here, we're one and done, because nothing goes into both of those except 1. So this is what we're looking for. Now let's look at, go ahead and work 9 and 10. Pause the video, work 9 and 10, and then we're going to come back and work the last 2. Okay, I'm assuming you have worked 9 and 10, and now you're just here to check your answers. So number 9 is 6 plus 27. Okay. Well, both of those are not even. So let's check. You notice when it's not even, I check for divisibility by 3 first. So let's look at 27. 2 plus 7 is 9. That is divisible by 3. And of course, 6 is divisible by 3. So we're going to put our 3 here. 3 goes into 6 2 times, because 2 times 3 is 6. 3 goes into 27 9 times, because 9 times 3 is 27. Nothing goes into 2 and 9 except 1. So we're done. GCF goes on the outside. These two numbers go on the inside. You don't have to pull in any numbers other than what you have here. If you calculate your GCF correctly, this will be correct. So our last one, 36 plus 24. 36 and 24. Let's see. They're both even. So let's try 2. 2 goes into 36 18 times. You can do division off to the side to check that. 2 goes into 24 12 times. Ooh, well, I still got two even numbers, so let's try 2 again. 2 goes into 18 9 times. 2 goes into 12 6 times. So I have 9 and 6, and both of those are divisible by 3, so I'm not done yet. So you see how the upside down birthday cake or wedding cake or whatever looks. 3 goes into 9 3 times, 3 goes into 6 2 times. So now I'm down to 1 and done. My GCF is 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. Ugh, that doesn't look like a 12. So my GCF is 12. So that goes on the outside. And then on the inside, this plus this. All right, some of you probably saw the 12 right away because you're brilliant. That's wonderful. So that's this. We have a test tomorrow. And you know the test is not going to be long. So I don't want you to freak out, but I want you to do your best. Okay? So that's that part. Now we're going to get to the new part that we're doing today. And that's exponents. Ouch, almost fell. So this is a nice sheet that you can color. So this is how exponents look. This B is called the base, and N is the exponent. So what this means is B is multiplied by B N times. So I'm going to start giving you that so you can fill that in. So B is multiplied by itself N times. So go ahead and color that in. This is your base. You see that? And this N, that is your exponent. Now you will hear other words for exponent. You will hear power, raised to the power of. Okay. So this one, for example, if I have 4 to the third power, that's going to be 4 times 4 times 4. That does not mean 4 times 3. I'm going to get in the camera. Do you hear me? I don't have my glasses. That does not mean 4 times 3. 4 to the third power. We also call this 4 cubed. So we could say it that way, 4 cubed. Go ahead and write that on your paper. But it means 4 times 4 times 4. How many 4s do we have here? 1, 2, 3. So that's what that means. I'm going to multiply 3 4s there. 4 times 4 times 4 is 64. You're welcome to use a calculator on these to say 4 times 4 times 4. This is a shorter way to write it. Okay, so it does not mean 4 times 3. Do you hear me, people? It does not mean 4 times 3. Okay? So I need you to get that all the way down to your spirit, okay? Now here's the next one, which is pretty interesting. 1 to the 5th power. So 1 is my base, and 5 is my exponent. So that means I'm going to multiply 1 times itself 5 times. And y'all color these in. I'm going to color mine in tomorrow, and I'm going to post mine so y'all can see how pretty it looks. So 1 to the 5th power will be 1 times 1 times 1 times 1 times 1. How many ones do we have? 1, 2, 3, 4, 5. So that's the same as that. It does not mean 1 times 5 because 1 times 5 is 5. But let's look at 1 to the 5th power. 1 times 1 is what? I hope you said 1. So 1 times 1 is 1. Then 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. So 1 to the 5th power is equal to 1. You can color those in and make them cute. Okay. Let's switch colors. Blue. Now 3 to the second power. I'm coming into the camera again without my glasses. That is not 3 times 2, okay? If you do 3 times 2, Miss Sledge is gonna scream. So 3 to the second power, how many 3s will I have? Right, 2. So it's gonna be 3 times 3. Y'all see that? So 3 to the second power is 3 times 3, and 3 times 3 is what? 9. And this is also, if something is to the second power, we say it's squared. We're going to write that right here. When we say an exponent out loud, we call a number with a power of 2 squared. And to the power of 3, we say cubed, C-U-B-E-D. I'm going to move so that'll show up better. Okay, here's another thing I want you to learn. Any number, let me clear all this off and bring this up some. And close that. Okay. So if it's to the second power, we're going to say it's squared. If it's to the third power, we're going to say it is cubed. So if it's raised to the power of 3, it's cubed. And that should be squared. Now, any number to the 0 power is equal to 1. Any number to the 0 power is equal to 1. And you would have to know the property of exponents, which we'll learn next year, of division of exponents, to understand why any number to the 0 power is 1. So if I have 156 and I raise it to the 0 power, it is not equal to 0, it is equal to 1. Let's do a little song there so you won't forget. Any number to the 0 power equals 1. Any number to the 0 power equals 1. Any number to the 0 power doesn't have to take an hour. Any number to the 0 power equals 1. Okay? Any number to the 0 power is equal to 1. Okay? Any number to the first power is equal to that number itself. So if I had 156 to the first power, that would equal 1. Now, when you get into algebra, they're going to leave that 1 off altogether. No, I'm sorry, equals. Oops, let me say that again. I messed up. Any number to the first power is equal to itself. So 156 to the first power is equal to 156. Powers of 10, those answers will only contain 1s and 0s. Okay. So let's simplify a few expressions here. I need this out of my way. All righty. So 2 to the 5th power is 2 times 2. Wait a minute, let me do something, because we're in 6th grade, so we're not doing those anymore. So 2 times 2, I have to have 5 of these. 3, 4, 5. 1, 2, 3, 4, 5. Y'all see that? So it's not 2 times 5. I'm coming to the camera again. Get ready. It is not 2 times 5, okay? It is 2 times itself 5 times. So it's 2 times 2 times 2 times 2 times 2. And that is, I do not know. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 5 to the 3rd power, I'm coming again, is not 5 times 3. So it is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. I did not really do that quick. I just know 5 to the third power is 125 because I've been teaching math a long time. All right, 10 to the third power is 10. Well, I did my x. Times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. I want you to notice something about powers of 10. Notice that I have a 1 and 3 zeros. So when you raise something to a power of 10, this number here is going to tell you how many zeros you have. Got that? Well, they got another one, so we'll get it. 12 to the first power. So we know any number to the first power is equal to itself. So that's simply 12. 10 to the fifth power is not 50. It is 10 times 10. So we have 5 of these. 3, 4, 5. But remember, I told you before that it's going to be a 1 and that many zeros. 1, 2, 3, 4, 5. So it's 100,000. 10 to the 13th power, it's going to be a 1 and how many zeros? Right, 13. Y'all are so smart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I'm going to put my commas in there. So it's a big number. Okay, so that is all I'm going to do for today. I want you to do that. Do that. Color it in. Color this sheet in. That's what I was trying to say. I want you to color this sheet in, and I will see you all tomorrow. And well, I'll see you today during office hours, and I'll also see you tomorrow. All righty.